I'll record in this computer. And one thing. Fine. Good evening, all. So in this particular session, so we'll talk about pandas. Okay. So what is pandas? So generally, like how we saw Numpy. Numpy was a numerical Python. It's a library, okay, which was built, over Python. So that means it was using the Python programming things, but it was having its own set of classes. So with the help of which we could work with two-dimensional arrays. Fine. So it was having a lot of built-in functionalities. So to access the data in the form of rows and columns, that is the access, we have some kind of functionalities for reshaping, line spacing, and the various things. Fine. So today we'll go one step ahead. So we'll talk about pandas. So it's a library for doing the data analytics. Okay. So you want to analyze the data. So what is data analytics? When we have a large amount of data, you want to put some kind of a questions on that particular data. Okay. So how frequently the data is repeated, or what is the average value, something like, I say I have some kind of a sales data. So I want to know this particular product, how many times it is being sold in this region, what is the percentage of sales or something. So those kind of, you want to put some kind of a questions to extract the data. So we use this particular kind of analytics. So pandas is a tool, okay, so which is used for making this particular data analytics more easy and convenient. Okay. So it says
Right.
Pandas is a software library which is written for the Python programming language. So that means it is a library written by the third party. So for the Python programming language. So that means this library can be used in the Python programming. For data manipulation, the purpose of using Pandas is it is used for data manipulation and the data analytics. Okay, why Pandas is used? So Pandas is mainly used for data manipulation and analytics. In particular, it offers the data structures. That means it provides you different ways to do this. Okay, and operations for manipulating numerical tables. So again, here we work with something called as a tables. Tables is what we have the data in the form of rows and columns. See, in the case of NumPy, we were working with 2D arrays, two-dimensional arrays. So we had indexing to access the rows as well as the columns. When I talk about a table, table will have the row index and also the column index, but will have a custom names we can define. So you can define the own names for this particular things, both for the column as well as for the row index. We can define your own custom name and you can access. So something like you're putting the data in a Tableau format and then working on your data. So more like I can say working with your databases. Okay. It offers structural and operation for manipulating numerical tables and the time series. It is built on top of Python programming language. Okay, I think. And also, like, Pandas is built over NumPy also. So we saw the kind of benefits of using this particular NumPy. So NumPy benefits was it was fast, it was more memory efficient, it was more convenient programming. So since it is built over NumPy, so it has the similar kind of things. It consumes very less amount of space. Okay, it is more efficient and also it's more convenient since it has provided with lot of classes and the functionalities. What is data? Okay, so mainly like pandas is used for doing the data analytics. Okay, thing. So yeah, data analytics is a process of analyzing the large set of data points to get some answers on the questions related to the data set. So you have some huge data set. On that particular data set, you want to know what is the average sale, what is the highest sale, the lowest sale, or region-wise sale or something. So those are kind of a questions. What is there? You want to get the answers for that particular questions, or what was the sale for the last 3 months or last 6 months? What is the sales? Okay, so those kind of questions we put, and we expect the answers for those particular questions. So any software which gives me this kind of functionalities features is called as a is having the feature of data analytics. Is data analytics is a process of converting the data into a useful information. You have some data, So you want to make that particular data a more meaningful data. Fine. Then Pandas is a Python module that makes data analytics easy and more efficient. That is the use of Pandas. So I think you understood Pandas. So here Pandas is nothing but a library which is mainly used for which is built over Numpy. Okay, it is used for rating. It is using the programming syntaxes of Python. So since it is built over Numpy, it has the benefits of Numpy, like it occupies less memory. It is what you say, more efficient programming and more convenient programming. Efficient programming is it's going to be working very faster, okay, and more convenient is it comes out with a lot of built-in functions and procedures. Fine, okay, yeah. So it is a module mainly used for the data analytics and analyzing the data. Now, you want to do this particular data analytics, we have different ways to do it. We have different structures, okay. So to do this, so we have two main structures here. So we call that as a series, that is Pandas series, and the data frame. So generally when I talk about a series is one dimensional, so 1D, okay, one dimensional labeled homogeneous arrays of size immutable. So means, so series are mainly used to work with a single dimensional array, one dimensional array, not two dimensional array. Whereas the data frames are used for working with 2D arrays, two dimensional arrays, where the data is in the form of rows and also based on the columns. Fine. There are two structures to work on Pandas. One is your series, another is your frames. So series are working with a single dimension, that is a single column tree you're working on the single column data. We use this. Whereas in the case of data frame, it is mainly used for a 2D. And labeled means 2D means like row by column, and the rows also will be labeled, columns also can be labeled, and you can work on that. And heterogeneous data is, that means each column can be of a different type. So one column can be a string type, another column can be a floating type, integer types, and things. Okay, so there are two ways of series and the data frame. So today we'll see with the series, okay, and then later in the coming session, so we'll look into the data frames. So when I talk about this Pandas series, so Pandas series is similar to a Numpy, okay, a one-dimensional labeled array. So that means in the case of Numpy was working with two-dimensional, but there was nothing called as a labeling of that particular rows and columns. So we always have to go identify that particular any value based on the index 0, 1, 2, 3, 0, 1, 2, 3 columns and so on. So I can say that is a kind of a drawback what was there. So now here it says it's a single dimension, but again each field can be identified with a column name with extra function. Okay, plus okay, it's same like Numpy with one dimensional labeled array. So that means array will be labeled and with extra functionalities. Okay, so it has some additional functionalities compared to your Numpy. We'll look into what those additional functionalities, and also capable of handling any type of data. So that means when it comes to Numpy, it was mainly working with the homogeneous values of a single type. So whereas here, okay, even though it's a single dimension, but each value can be of a different types, and it can work with integers, can be working with the strings, floats, etc. Fine. Yeah. Now, Panda series can be created. Okay, we have different ways to create a Panda series. Okay, we'll just see like how. Now we'll come to a practical session where we'll see how to exactly create a Panda series. So what is the Panda series? So Panda series is one of the data structures under the Pandas. Okay, so which is mainly used for 1D. Okay, one dimensional labeled array. Okay, you're working with, and it has more functionalities than Numpy. Now, if you want to create this particular series, so we have different ways to create the series. We can create with the help of the list. What was list? List we saw within the regular Python. So list was nothing but a group of values. Okay, we can work. We can also work with the Numpy array. So that means you can create a series based on the Numpy array. You can create a series even based on the dictionary. Dictionary is something which contains the key and the value pairs. We can also create a series based on the scalar value. So generally, what is a scalar? Scalar is a single value. So you want to have one single value repeated for the multiple columns. Okay. we can do it also. We can create the series either based on the list, array, numpy array, a dictionary, or based on the scalar values. Fine. So we'll get into this. So we'll just see one by one. How do we create this? Here, I'm just showing how do we the construct. So how do we actually construct the Panda series? So you want to construct a Panda series. So we do it like this. So the under Pandas, we have this particular method called as series. This series method takes the different parameters: data, index, data type, and the copy, out of which data is the only mandatory part. So the rest all are optional. So data is, that is, as I said, the Pandas can be created based on the list. It can be created on based on the array or a dictionary or a scalar value. We need to say based on what value you want to create a series. Index is, if I'm not giving, see, like, when I say it is going to contain multiple values. Now each value you want to identify an index. So by default, index will be given like your numpy array. So index will be 0, 1, 2, 3. Now you want to override the 0, 1, 2, 3. Instead of 0, 1, 2, 3, you want to say 1, 2, 3. Or you want to give an English names. You can define that in the index. Okay, now the data type is, this individual value will have a specific type. So you can say what type of data it is. Fine. So see, that means here when I talk about data takes the various forms like array, list, constants, or any this one. Indexes values must be unique and hashable, same length as the data. Okay, the default MPy arranges number of indexes being passed. So that means by default index will be given a 0 base. So you can give your own custom index. Data type is for data type. If none, data type will be inferred. So that means depending what type of data it is storing, so the system will automatically decide the data type, either as a string or a float or int thing. Copy data is your default. By default, copy data is false. This is like, you want to copy the data from the another series into this. Okay. So we'll see how do we implement this particular thing. Okay. So the series can be created using any of this particular existing objects. Okay. So these are parameters, out of which only data is a mandatory and the rest all are optional parameters. Okay. So now let us take an example here. How do we create a series, a Panda series, using a list? List is nothing but is a group of values. For doing that, just like how we imported NumPy, we need to install this particular library. So if it is a PyCharm, we can just go to the project settings. We can go to the installer. Okay, in the interpreter, we can install this particular thing. Or if we are installing in the Python, we can use the pip install pandas. So this is going to install. So one thing is, if you're installing pandas, we need to ensure that you have already installed NumPy, and then you'll be installing. First, you need to install NumPy, and over that, you'll be installing pandas. Once you have installed pandas, we are going to import that particular pandas library. So how do we import? We say import pandas. Okay, this is going to import the pandas. Now you want to refer this pandas with the alias name. Okay, we are using this alias name as PD. Okay, like how we use NP for the NumPy. So we can use an alias name, a simple, easy to call name kind of thing. So you can give any name, but generally pandas is referred as PD, NumPy is referred as NP. Okay, so this is just I have imported pandas and I'm telling that, okay, again, an alias name for pandas is PD, easy to call that name. Fine. Then now when you look into this one, what is this? So this is nothing but a list. Anything which is in the square bracket is a list of marks. Okay, so 23, 21, 34, 43, 26, these are nothing but is the marks. Okay, so now this particular list of marks is there in this particular variable, or I can say this is a list, since anything which is given in the square bracket is a list. So here marks is a list which contains a list of marks. Now you want to push this particular list into series. So you can see here I'm telling pandas.series. That means PD is an instance of a pandas or alias of pandas. So using that, I'm calling the series method. See, pandas is case sensitive. Python itself is a case sensitive. For most of the methods, what you use in pandas are starting with the uppercase. You can see series ka S is caps. This is the case sensitive. If you write a small series, you will have a small s. As series, you will have an error. Compiler will not be able to identify. So pandas.series, And then you can see I'm referring this particular marks here. The list is referred over here. Okay. Now this is my new series, Panda series marks. Now I'm just trying to print this. This is going to print the series. So let us write this and execute this particular program. So I will get into my PyCharm. Okay. Take an example here. I've just written this particular series here. Okay. So the same marks here uh, is a list which contains a list of marks. Print marks. This is going to print the normal marks. Okay. This is not series. This is a normal list. Okay. So yeah, when you look into this, this is my regular list. I've just created a list and just trying to print that list. Now what I will do is, okay, so I'm trying to find out what is the type. It is a list. Now you want to create this. So since I have imported this pandas, I'll just say, okay, series. Okay, I'll just say s is equal to pandas dot series. Sorry, pandas pds dot series. Okay, and then what is that series here? Okay, that is your marks. That is a list. So now you can see print. I'll just print this. Yes, I'm just trying to print that particular series here, so we can see what happens. Yeah. So this is my list. I'm just trying to print that list. Okay. So this is my list, and you can see the list is printed something like this. Okay. The same thing I converted. I just added this particular thing to the series, pandas.series, and I call the same list. Okay. And then I'm trying to print that series, print S. So print S is printing like this. So that means we have those marks 34, 15, and all this particular marks. And you can see they have given with the index. So it is, okay, I have not given an index. So by default, the index is given as 0, 1, 2, 3, 4, 5, 6. 6 subject marks are there, 6. Now you want to give your own index. So we can just say comma. I want to call this particular index is equal to, what is the index that you want to give? So I just say something like 1, 2, 3, 4, 5, 6. Okay, how many marks are there? 1, 2, 3, 4, 5, 6, 7. See, actually here what happens, we have 7 marks and my indexes are only 6. Okay, that is the reason it is conflicting. So I just need to pass this. Yep, sorry. So now you can see, yeah. So that means instead of 0, 1, 2, 3, it is given as the first, second, third, fourth. Or you want to give your own custom. Like I say, this is a subject 1. I just say it's a subject 1. And just say, come on. I just say this is a subject 2. I say it is subject 3. Subject 4. I say it is subject 5. It is subject 6. Subject 7. Okay, so I have some kind of a 7 different subjects. So it just tells me, or some names of the persons. Okay, so anything. So we can just pass that Sam, Tom, Ben, or something. It's fine, cool. So we have this. This is the labeled index. Okay, you can give your own. So if I'm not giving this particular index, so in that case, it is going to be a default one. 0, 1, 2, 3, but you can redefine, you can customize this index. So this kind of an indexing concept was not there in NumPy, not in the regular Python, so neither in the NumPy, but it is introduced with the Pandas. So this is just the series 1-dimensional. So in the data frame, we'll see with the 2-dimensional things. You got it?
Yeah.
Okay, fine.
1 second, sir. I'll just make a note of that.
Okay, okay, fine.
Printing, we always use this hyphen n backslash reverse slash.
I never used it. So if I put this, so what happens? You get a new line. So otherwise it will be continuation. See, if I'm not using this, so you get something like this. So it is continuing. The first row is here and then it is second row. So when I say slash n, it is just a new line.
Do we have to include both NumPy and Pandas? Because Pandas is a part of NumPy.
Right now it's not any that is there. Not required. Not required all the 6 steps. Yeah, so it should be fine. So it is very simple. It is only this much. We have some marks. Okay, so we just say this is a list. I'm putting into the series and then printing the series. That's it. Instead of directly printing, it's just this one single line. It is converting that list to a series. What is the benefit of that? I'll show you. So it has a lot of built-in functionalities and things. Yeah.
If you just run it this way, what will happen, sir?
This way you'll get with the zero-based index. So you can see here. See, before it used to be only this much, and that it was in the horizontal. Now it is in vertical. So because it's a 1D, one-dimensional array. So and you can see every index has been given 0, 1, 2, 3. Index is zero-based.
Okay,
index.
the first line, if I don't need that space.
Which space?
नहीं, series colon उसके बाद 0 एक space है ना, space 0. Output पे है sir.
Okay, okay. That additional space it has come. I know why it has come because I saw many times in every this one it is coming. Even if I'm not giving this, still that space will be coming.
Correct, correct, correct.
Oh,
It doesn't come.
So print alag isme डाल. So I'm going to print this. Yep. Just to say this is a series.
Right. Custom बनाने के लिए क्या है sir?
Custom बनाने के लिए custom index. So we यहाँ पे comma देखे. We just sorry. Comma. I'm just trying to give the index. Okay. And as of this one is a function, you can just say I say this is the marks of the different student. Okay. Marks of different student. I just say something like Sam. I say France. And 5 names are there. So we need to have 6 names. Yep. This is making more meaningful. Exactly telling like, you know, kiska marks hai wo.
Right. वो क्या था? D type is int 64. वो क्या है?
Data type. Data type is, see, like I want to know what type of data it is. So I just say print s dot data type. So right now, since you have given this particular numbers, okay, you can see the data type is given as int 64. Int 64 is
Right.
nothing but 8-byte integer. 8 into 8 is 64. 1 byte is 8 bits.
Right.
Okay, so it is going to be 64 bits. So now I say this is, but we have the data is very small values there. Yeah, so you want to give us more. See, that is going to be 64 byte ka each field. So 64 into 6. So that much of space is being occupied. So what we will do is here.
नहीं.
Yeah, I will give the new data type here. I say d type is equal to, I'll just say it as int. So when I use this as int, you can see int is 4-byte int here. It is occupying 4 bytes of memory. So I want to use a smaller int, maybe byte ho sakta hai. Byte. So it is bytes. You know. And 16B. So before it was a float, 64 is float, and int is 32. So I'm changing this particular to the best data type. See, since I had not given a data type, it was given a default type. So default data type, it is going to take the type which can accommodate any type of integer values. So 64 is 8-byte. It can store single, double values, big integer values, and all these things. So, but you know, each byte, each value, it is occupying 8 bytes of memory, which you will be just wasting your memory space and things. Okay, so you want to redefine the data type. So if I'm not giving this, this is going to be int 64. Okay, when I say it is int 64, that means each byte is occupying almost double the space. So which can be accommodated in the smaller integer values. So we can redefine that particular data types. So it will occupy lesser memory and lesser space.
No, my question is, why is it printing D type over there? Have you initiated it anywhere?
No, this one is it?
No, before that. Output pe sir.
Output may. Okay. So without this also it is giving in the output. It is telling like, you know, by default it is telling what data. Yeah, this is what it is in the, when it is showing the output, it even tells you what type of data it is. Yes. So output of series, even in this one also you will get, no? The list also.
Acha.
सीरीज में नहीं, लिस्ट में नहीं आ रहा है, इसमें by default it is printing.
अच्छा.
हो गया? Scouts. Okay, this was like how do we create a series, a panda series using a list. Fine. Next thing is, yeah, this one is how do we create a series using a string values. Okay, see in the slides, in the previous slides I had told, so we can create a series not only with the integer values, you can even work with the string values. So in the case of NumPy, we are only working with the numerical data. Here even I can work with the non-numerical data, strings and objects and so on. So what I've done here again is, this is my list. I just have some names. Okay, list of names, string values. Now, okay, I want to assign this into the series. I say pandas.series names. So this names, the list we have converted to the series. We have assigned to the series. Now, when I say print name n, so this is going to print, okay, that particular names. Fine. So you want to work with that particular strings. So you want to create this particular series using it based on strings. Okay. So what I do, I just say names is equal to, okay, I think I'll just copy and paste this code. I think. Yeah. Okay. I've just created this particular names is equal to, I've just given this particular list of names. N is equal to pandas.series of names. We are just calling this particular names, and then we are trying to print this particular names. Now, if I try to run this particular program, so what will happen? The names are stored in this series, and then we are just trying to print these names. So if I run this particular thing, so you can see, okay, by default, it has given the index 0, 1, 2, 3, okay, and we are just telling the names. Okay, so we can even define your own indexes, and all these things can be worked on this also. Fine. Okay, now here we have a thing called as a describe. Okay, describe is what you want to give the detailed information about that particular list. See, one thing was the data type was telling what type of data. You want to get the complete information about the list. We have something called as a describe. So let me use a describe for the marks. Okay, the marks series. So I'll just say print. Okay, I just want to describe. So I'll just say that is, what is the name of that? S dot describe. Okay, so when I try to run this, so what happens, it gives me the detailed information about the marks. So that means, like, you know, here it says how many marks are there, totally 6 marks are there. So what is the highest value, what is the lowest value, what is the standard deviation in the marks, okay, how is the deviation of the marks, what is happening, what is the deviation at stage, 25%, 50%, 75%, how is the deviation. Okay, so we are trying to get this kind of information also. Like, you know, when you saw with this particular NumPy, we had that std function to find the standard deviation. We had a mean function to find the mean, count function to count min, max, was all this is a separate function. But here I have those particular function individually, we can work on it. But apart from that, we do also have something called as a describe, which gives me the detailed information about this particular series. Okay, it gives me some kind of a statistical information. So how many values are there, what is the average value, standard deviation, minimum and maximum, and the deviation at a different stages, 25%, 50, 75%, and so on. Now the same thing you want to do the describe, okay, for this particular names. So what I do is I just say print dot describe. Okay, so when I describe this particular names, so you can see what happens here. So we have this particular thing here. Okay, so Sadiq, Sam, Scott, again Sadiq. So it says data type is object. Count how many values are there? 4 values are there. Out of this particular 4 values, how many unique values are there? Distinct values. Say Sadiq is there, Sam is there, Scott is there, but this Sadiq is repeated value. So only we have 3 unique values. So that means the most number of times the value which is repeated the maximum number of times, or like, the salesperson which has been repeated than the most number of sales. Okay, so you want to get those kind of things, the top repeated. So how frequently this is being repeated, the top, this one. So we get this kind of info. So that means we get this kind of additional informations. Okay, even with this particular string series, that means we have created this series based on the string list of string values. Fine.
Yes, sir.
Okay, fine. So that was like, how do we create a series based on this particular list? See, we have this particular functions that can be done with the help of the series: count, min, max, mean, sum, average, and all this thing. Like, say example, I have this particular thing. So I just want to know what is the total marks. So I want to know what is the total marks. In that case, what I do, I'll just say print. So that is the series dot sum. So sum is giving me as 304. Yeah, describe, I'll just remove. 304 is the sum. So I just want to say print is dot. We have that particular count. We have the mean. Mean will give me the average. We have the standard deviation. We do also have something called as a cumulative max, a cumulative sum. See, I've just used this particular thing here called as a S dot cumulative sum. Now we have this particular SAM, it is 34. Okay, this is this one, and so on. So now, say, take an example, like the sales have happened at the individual month wise. Jan, we had some sales. Feb, we had some sales. So I want to know the total. This is a total of all the sales. But I want to know, okay, Jan, what was the sale? In the month of Feb, I want to know from Jan till Feb. Okay, Jan till March, I want to know what it is. So it is something like that. So you can see the SAM, okay, value was 34. When I went to this particular Francis, it is nothing but sum of this two. 34 plus 15 is 49. So when I look into this one, it is the sum of these three values. Okay, then it is sum of four values, sum of five values. It is doing a cumulative sums. So this will be useful like when you're doing a quarter-wise sales, okay, month-wise sales, week-wise sales. So you want to see the totals as well as you want to see the cumulative, how it is growing. Yeah. So like those kind of a statistical things you want to give, so you can do. So there are many cumulatives, no?
Yeah.
Cum max, cumulative product, and those kind of things. So this cumulative sum wasn't there in the NumPy and things. Okay. And then describe is an additional function. We have median. Mean was there. Mean gives me the average value. Is it?
Correct.
Mean gives me the average value. So that means if it is 304, so for 6 subjects, 304 divided by 6, okay, 50.6. Clear? Okay, so mean is giving like this. So we do also have something called as a print median. Sorry, series dot median. So what this particular function will do? See, median is giving us 50.5. So what it does is it tries to give me the middle value. Middle value. How the middle value is given in this? How exactly the middle value is given? So first thing what it does is the data will be sorted. So data will be sorted. We say 15, then 30, so lower to the higher value, and then tries to find out what is the middle value. Okay. So that means in this, if I sort this data, so it is going to be 15. And then 33, no? 33 and then 34. If you put in order, so then it is 67 and then it is 75 and then it is 80. Fine. So if I put this in an order, so you get the value something like this. Now out of this, what is the middle value here? So middle value is, if it is an odd number, I'll get a middle value. But here, since an even number, these two are the middle values. So since these two are the middle value, it will give the average of these two values. The average of these two, that is 34 plus 67 is 101. So if you do this particular addition, so you will get the value as 101. Fine.
Right.
That divided by 2 is nothing but 50.5. So that is how it gives you the middle value. Median. Okay, this is a statistical function, very useful kind of things. Okay, so this function wasn't there in NumPy. Mean, sum, count, and all these things was there. Okay, median is something like new. So okay, apart from the standard deviation was there in the NumPy itself. So those particular things are there. So that means it is built over NumPy also. It has all the features of NumPy plus more additional features from there. Okay.
Yeah.
Yeah. So I'll just take 2 minutes break.
Sure. It didn't go anywhere.
Okay. Fine. So we have seen how do we create this particular array using the list of string values. Okay. First we saw the list of numerical values, list of string values. Next is we'll see like how do we create this particular list using the array. Okay. So array can be generally array was there in NumPy. Is it? So in Python, list itself is like an array. Okay. So we'll just see like how do we do this. So when you look into this, so I have importing the NumPy. I say np.array. So I've just defined some values here. So again, I've just because you know series works on the single dimension, not on 2-dimensional. So we cannot give a 2-dimensional. For 2-dimensional, that is where we go to the data frame. We'll see that in the coming session. So I'm just creating this 1-dimensional array, and that we are assigning to this variable data. So I say pandas.series. I'll just specify the data. So that means this data, that is array, will become a series. So that means when I make this as series, I'll get the series functionalities, statistical function of the series and all those things, right? Apart from that, so we can give an index. So we have given the index here. So see here, we have given the help of the range is optional. Okay. We can also define the index using the range. Okay. I think first we'll see like how do we define this based on an array. I'll use import NumPy.
Okay.
Okay. See, we can import like this, or we can just say from NumPy import star. Okay. I'll just use one. And then, so we are declaring this particular NumPy array. So we have just given a one single dimension, and this is series is equal to this. Okay. And printing that particular series. That does not have the range. It's simple. So we have created this particular array, and then we are storing to the data, and the data is being passed on to the series. So we just say pandas.series, and we are taking the data, and this data is nothing but your array. And when you try to display this, it just works. So you'll just have the values 1, 2, 3, 4 with the index as 0, 1, 2, 3 and thing. So now you want, instead of telling us 0, 1, 2, 3, you want to have your own custom index. So what will we do? Okay, what we will do in that case. So in that case, I can just go with this comma index. So since it is 4 values, so I can just pass the 4 values. Okay, just say something like say 1, 2, 3, 4. So it'll just print with the index also as. So that means you are getting an additional column here. Okay, which is nothing but your headings, row headings. What I mean to say. So and that we can define. See, in this case, what we have done is we have given this indexing with the help of the range. You know range, no? Range is nothing but we used in the for loop. I say I want to start from here, it has to go till here. So now I want this particular range to be given starting from say 101 and I want to go till 104. Okay, so we know that when I use this particular range, Okay, so by default it starts from 0, and if I just say it as 105, sorry, if I say 5, so what will happen here? It is going to be 0, 1, 2, 3, 4. Okay, that means we have 5 values, but here we have only 4 values. So this will definitely throw you an error. So when I say 4, so you can see index will be given as 0, 1, 2, 3, 4. Yeah. So this is my index what is being generated, and you can see the index is generated based on the range, and by default the range starts from 0 to n minus 1. Fine. But I say no, I don't want to start from 0. I want to have a series of 100. So I want to start from say 101, and it has to go till 104. Okay, so that means it is n minus 1, no? So always the start ending is n minus 1. So it will start from 101. So that is going to be 101, 102, 103, 104. So now you can see the index is given as 101, 102, 103, 104. So that means when you see, like when you have a large array, the large element, so then again, and you want to generate this particular sequence with a sequence number, instead of writing that particular indexes in the sequence 1, 2, 3, or you want to have your own custom start and end and all this thing with the increment and all these things, so you can do. Or I say I want to start from 100 and I want to go till 50. Okay, and I want to increment with plus 10. So it is 100, 110, 120, 130, 140, 150. So that is, it should go till 140, is it? Yeah. So I have given a series with the increment of plus 10, 100, 110, 120, 30, 40. So this is my custom index, what I have defined. So now again, like, so that means like, when you have a large values, frames. So in that case, I can take the help of this. So I don't have to keep, okay, writing that every incremented values, I can define it in this particular range. So that means we can define an index even as a list, as a function, as a numerical value, or it can be even given as a range. Clear? Escorts.
Yes, got it, sir.
Got it. Okay, fine. Okay, that is what is there in this particular slide. Creating a series using an array. Sorry, this is using a dictionary. Okay, now here we are trying to create a series based on a dictionary. Okay, what is the dictionary? So generally in the dictionary, what happens, the data will be stored as a key and value as a pair. Okay, so now this is my Python dictionary. So in the dictionary, you can see dictionary is given in the flower brackets, and every key it is stored with the key and the values. So it says BLR, we have some value, Delhi. Okay, this is something like, imagine it's the sales data. So this is sales in Bangalore, this is sales in Delhi, this is sale in Hyderabad, this is a sale in Chennai. I've just given this key and the values. Okay, so that is my data. That is my dictionary data, which is there in my regular data. So that I'm converting into Panda series. So I'll just say pandas.series, this particular data. So now what is the value stored in S is nothing but the series of this particular data in the series format. And then we are trying to print. And when you print this, so you will get like this. So whatever the key is there, that is going to be your index. And whatever the values are there, key value pairs, no, the values will become as the actual values. That is creating a dictionary, creating a series with the help of a Python dictionary. I think I'll just wait. Yeah. Got it?
Yeah.
Okay, that means we have created based on this dictionary. So if you have created based on the dictionary, the keys will become itself as a index key and the values are there. Okay. The next thing is your dictionaries can also be created using a scalar value. What is scalar? Scalar is a single, using a single value. Now you can see we're telling directly, we are not defining any kind of a list or array or a dictionary or anything. So I'm directly telling pandas.series 100. So 100 is my data. Okay. So when I create it, it's going to be have one single value as 100. But you can see I've given an index here 1, 2, 3, 4, 5. So that means it is going to have 5 rows and each row will be indexed with 1, 2, 3, 4, 5. So this will be automatically what happens, it will be same value will be repeated for every index. So this is going to be my key that is based on the index, and the scalar value, single value, same value is repeated for all. Okay. So it can also be created using the scalar value. So that is, we saw how do we create a series. So the series can be created either based on the list. It can be created based on the list of numerical data. It can be created based on the list of string data. It can be created based on an array, NumPy array. It can also be created based on the dictionary. Apart from that, it can also be created based on the scalar values. Fine. Okay.
Done, sir.
Now, once you have created this particular dictionary, series, what is the use of that? So use of this is generally I should be able to access the data. So that is like, mainly we saw this is used for the data analytics point of view. So data analytics means like, we have some kind of a huge data. In that particular data, I might be putting some kind of question. What is the average sale? What is the highest to lowest? Or a sale based on a particular percentage. I say, okay, in Bangalore, what was the sales? Or what is the sales by done? Or what is the marks scored by Mr. Sam or Sadiq or something? So in that case, okay, I want to extract those particular data. So we'll see those kind of functionalities. What we have seen is, we have just seen how do we create it. Okay. And things. So with the help of different ways we can create. Yeah. Next is some of the similarities between NumPy and series is accessing element is almost same. So we have the indexes. Here also we use the indexes. We can also use the loops to iterate the values to read the data from the series. We do also have a lot of convenient functions we saw in the NumPy. The similar kind of convenient functions are there in this. So like say sum and all these things what we saw. Okay. Apart from that, we have a little more functions like cumulative sum, cumulative products, cumulative mean. Okay, so you want to find, okay, you want to find an average at every stage. Okay, what it is. Okay, we also have something called as vectorized operations. We'll look into details of this particular vectorized operation. So actually, this wasn't there in the NumPy. Okay. So now accessing the elements of the series. Now you want to access the elements of the series, we access based on the index. So that is the series, and when I say 0, so this is going to get me the first value. Okay, so you can also do a kind of a slicing. Slicing is you want to get a portion of that particular elements. Okay, either from the starting or ending or a particular range of data you want to extract. So we use this particular concept called as a slicing. So you want to do the slicing. So we use slicing and all is similar like what we did in the regular list as well as in the NumPy. So similar kind of thing. Again, it is one dimensional. You don't have a comma, row and columns. It is only based on the one single dimension. So when I say I've given colon 3, that means I want to start from the beginning and I want to end at the position 3. So that is what it is going to be here. So what we'll do. Okay, I think we can have this particular list here. Okay. Print. I just say series of 0. So this is going to get me the first value, what is there in the series, which is nothing but your 34. Yes, we got 34. Fine. So now if I just say something like colon 3, so that means I'm least bothered of the starting. So it has to, I've not given anything. So it has to start from the very initial and it has to end with, okay, the third position. So that means it is going to fetch me the data as like 34, 15, and this one. So that is 0, 1, 2. So that means when it is ending, it is position 1, 2, 3, 67. The first 3 marks or the first 4 marks, it is 4. So if I start from 1, so 1 is the index 1. Index 1 is this. So it is going to get me only 15 and 67. Okay. So let us see if we can get it based on this name. Yep. So I want to know what is the marks of Fiza. So Fiza marks is 67. So this is some kind of a better thing here, which we can see in the Numpy as well as in the case of list. So there we always used to work with the index. Fine. Here it supports the index. Even though I have overridden the index with the custom, still that default indexes are there, 0, 1, 2, 3, a 0 based index. We can read the values based on the 0 based index, or even you can go with the custom index names what you have defined. Okay. So I just wanted to find the marks of this or something. So you should be able to. Okay. So maybe we'll try to find out. I want to find the marks of Fizon and say Sadiq. Yep. So if you want to get with multiple, you need to give a nested, okay, list, and there you can use a comma and you can just get it all this. Sam and thing. So this is going to be Sam and Sadiq. Sam is 34, Sadiq is this one. So I just want to get the data in a range. You don't have this option. So of the range. So alternative values you can list. Fine. So that means when you are slicing, so all the slicing features are there. So this is start from the index 2. That means the third field, go till the end. So this is starting from the index 1. That is the second position to the fourth position, second, third, and fourth. So we'll get. We cannot use a negative indexing from the last -2, -1. So that will not be allowed. So apart from that numerical indexing, we can also use this one. So, okay, so this can be more easy, more way to extract the data. So indexing will be useful when you're using the loops and all these things. Okay, you want to retrieve multiple values, you can define the start and end of the loop. So, and then you can just say matching based on the index you try to read. Okay, but you want to retrieve values based on the identifier, the names or things. So we can use it something like this. Fine.
Yes, sir.
Okay. कुछ नोट है नहीं ना?
सर 1 मिनट पॉज करेंगे रिकॉर्डिंग.
Pause हो गया? Okay, okay.
नहीं आप पूछ because
you are going to
of
pause
me.
in this.
अच्छा रिकॉर्डिंग हो रहा है.
नहीं मैं बोलने का आप मीटिंग के बाहर रहेंगे या
आपसे पूछा रिकॉर्डिंग पॉज करने के लिए.
अच्छा नहीं मेरा ये था you'll be attending the sessions no.
नहीं वही पूछ रहा था, वही बता रहा था कि आप you continue anyways if you're recording I will catch up with the sessions.
Okay. नहीं what is the reason?
Because मेरे वजह से उनको I don't want them to lag.
नहीं the reason I just want to know.
Reason because I just want to brush up everything from the beginning so that I just want to catch up.
The thing concern is, see, after tomorrow, even we are a little busy with the festival. So we have on Wednesday, we have Shaban. I think Fiza also will be busy with that. Yes, Fiza.
Acha.
Fiza is there.
She is on mute.
She's on mute, I think. Because Wednesday we have a festival. I think Wednesday, Thursday, most of us will be fasting. And Friday again you have Easter, Good Friday, no?
Correct.
Yeah. So I don't know how's your plan for the Good Friday thing. Because tomorrow I'm free, but Wednesday I need to wind up the session early, or I thought like, I can take one session on Wednesday. I think because it's a festival in the evening.
Recording pause कीजिए ना. I mean, I don't want all these things to get recorded.
Yeah, pause.
Or else if you want to break it.
Sorry. When we did the actual Python, we are doing with the concept of slicing. But here what we are doing is, here also we are trying to do the slicing. But you can see the slicing is enhanced here. Okay. When it comes to the NumPy, we were working with a 2-dimensional. So we are doing the slicing based on the row as well as the column. That was a new thing we saw with the comma separator. We specified the rows and we specified the column things. And then what we did is, so when we went to this particular pandas, pandas may again, so we are doing this particular slicing. So there is an indexing, there we have a custom indexing so that we could do it. So apart from the custom indexing, so we can do the slicing not only restricted to the numbers. So, with the numbers, every time going there, counting and then rewriting was a very, very tedious work. But there was no other go, we have to do that. But here what you are trying to do is, okay, we are defining your own custom names and we are identifying based on the names. Okay, so we just have some kind of a sales data, or it might be a kind of a weather data. You want to do some kind of analytics. So I want to know what is the average weather in the month of March, what is the highest temperature in the month of March in the year 2020, or last 5 years, say, what is the kind of average temperature for the month of April. Okay, I want to find out, and then I want to do a prediction. So how this April is going to be. Okay, so those kind of analytics you want to do it, so we can do it, okay, with the help of this particular things. Okay, so now we are just, since we have started with this particular series, so series is just working on a single dimension. When it comes to the data frame, so we'll be working with the multi-dimensional. So we do have data frames and panels and all this thing, but we'll go with the data frames. So we'll look into the data frames and see, in the case of series, we saw we could create a series based on the list, based on the array, based on the dictionaries and various things. The same way, data frame also we can create based on the list. Okay, we can based on the array and dictionary. Apart from that, we can also pull the data from the external sources. It might be a database, SQL database or Oracle database. I can pull the data. I can pull the data even from your Excel file. Or majorly what happens is, when you're doing the analytics, the data is going to be very huge. So they'll not store in the form of Excel. When you store the data in the form of Excel, the files are going to be very heavy. So it becomes very difficult to transfer over the network through the web. So in that case, mainly they use a CSV file, comma separated value files. It just occupies very less amount of space, but this particular file can be easily opened in Excel. Not only in Excel, any of the data analytics tool, so like Python or not, it can be easily fetched. I don't have to use a delimiters and all to open those particular files. Those kind of features are there in that. Okay.
Okay.
Okay. I think then we'll stop here.
Yes, sir.
Okay. So Kal, you are there, no? Again, 2 o'clock for VBA, and then we'll take it further.
No, sir. Give me a day or two. I will, because मेरे को नहीं हो रहा actually. So just give me a day or two. I'll be back.